to my channel here, Bluer Than Blue Falcon, aka Matthew Puttersaki, for another RxJS live coding session. Today, as always, it's brought to you by the number 91 and the letter V. Always a nice shout out to my sponsors there. So today, we've been, let's kind of go back to where we started here. And we've so far have gone and looked at the very basics of observables, about what they are, then to creating our own with schedulers, trying to understand that just a little bit. Then we did creating our own observables from conversions, to using of, range, and generate, then going here to create delaying and polling via timers, and then we had our conversion using the from, which was kind of exciting, using from array, from iterable, from observable, and so on and so forth. So that was the majority of that day. And then yesterday's stream was converting events to observables. We had a lot of sidetrack questions there, but for the most part, what we saw was the just dealing with events. And yeah, I did have a few screw ups here and there, but that's okay. I did fix it in the code, and so if you're so inclined to actually look at the code from yesterday, the event emitter stuff now works, because I had to properly cast it here as a function that takes args and produces an any. So that was that, and that kind of showed you some of the basics here. So what I'm going to do is I'm going to open it up for people who want to join me on a live stream, and you can use this particular chat right here, this particular thing right here, to go ahead and join at any point. So so if you want to join and you want to type along or follow along in your in VS Code, go for it. We can start coding together, and I think going forward, it'll be pretty nice to have people joining along with me on our adventure. So where does that leave us for today? So what I wanted to kind of talk about is the transition of how kind of RxJS has evolved, and what this new thing of pipeable operators really is. So in the beginning with RxJS, we would go through and we would kind of dot chain everything. So switching to kind of code mode, we would do something like var obs, let's get rid of that, obs is equal to rx.observable.from 1 2 3 4 dot map x and x times x, and dot filter, and x mod 3 0, and so on and so forth, where we could dot chain onto all of our operators. And that was kind of good for beginners, because at the time, people were very used to jQuery style of coding, where they can just dot into the next thing and continue on in a very fluent style manner. And that was pretty much what, if you were coming from a different background, whether it was Rx.net or RxJava or any of the other variants, it's pretty much dot chaining all the way down. The problem with that, and the problem that we reached with scalability concerns was a number of things. Let's go back here. So we ran into a number of things. Is like, what's the right amount of operators to include on that first day, basically. That's a hard thing to know, really. Is is it map and filter? Is it buffer? It was a number of those things, back in the good old days of when we did builds via Grunt and other tools, where we had to be pretty explicit about what we wanted to include. So we had this notion of splitting out time to virtual time to a bunch of different distribution files, and then you basically picked what you wanted to pick. And this is kind of the pre-modular JavaScript time that we're talking about, where not even require.js, there was not a huge adoption of require.js, and if you did, you weren't always guaranteed to get good adoption of your library and so forth. So what happened is that in and around a certain time frame, Lodash and others started trying to experiment with dot chaining and so forth, because libraries like Lodash didn't have that kind of thing. So they introduced the whole chaining operation, which is kind of exactly what we did starting in RxJS 4 and moving forward, which was you basically get to pick what you want to use going forward. So if you wanted to use a map or a filter or some other projection, that you could easily do so, and it just works. And since build sizes started to become a real concern for people, having the whole dot chaining wasn't exactly easy to tree shake what you weren't using. So, for example, if you weren't going to use a number of methods, they would still kind of be there in the code. So we had to look for alternatives to the regular dot chaining style. And so there we were, trying to figure out what was the right approach. And so in the RxJS 5 and 6 time frames, we started to standardize on this idea that instead of dotting on the prototype, we would give you this kind of transducer kind of pipeline where you can start to chain these together using a single operator called pipe, or a single method called pipe, and it would have any number of these operators that you could get. And it's really up to you in terms of which ones you want to pick, whether it's filter, map, buffer, blah blah blah, whatever it was. So all of that's really kind of cool, is the fact that now we are able to pick and choose what we want, thus making our bundle sizes a lot smaller, and it gives us a more lean and mean of what exactly we want to include and what we don't want to include in our library. Make it nice, lean, mean, fast, and not overly confusing in terms of what it brings in. So what you can let's actually talk about those piping operations. So it started in version 5.5, where you could require a certain path within inside the RxJS operators, where it says RxJS/operators. You remember that S, because there is always the compat things. Unfortunately, JavaScript has a number of limitations in terms of using methods as keywords as methods. So there was a number of things that you had to do to nicely utilize these pipeable operators, because you could say .catch on a prototype, or .do or .finally on a prototype, but you couldn't necessarily export a function called do or export a function called finally. So there was a little bit of naming, renaming that we needed to do along the way to make this really work for us. So with that, we had do becomes tap, which I had already been doing in the RxJS 4 days, just because I wanted to get away from those collisions anyways. And what's funny, going back to the history of the pipeable operators, this was always actually kind of possible with the let operator. And the let operator was basically a thing where you could do side effects in such a way. I'll actually show you exactly what I mean. We used to call them lettable operators, but it's not always the greatest name for them. So we could have said, const obs is equal to rx.observable.range, 0 to 100. Okay, and then we could say .let, and let would pass us in the current value, and then we could say x.map, or we could say map map.call, whatever. Whoa. Okay, it's getting a little ahead of me. But anyways, you could get that map function that we were exporting and call it directly, and then do all of these sorts of things where you say .let, and those were available pretty early on in RxJS, where you could do let, and then it became lettable operators, and then what people were pretty confused along the way and said, what the heck does let even mean? And I didn't have a good answer for them anyways. So with that, it became a lot better to name them, say, chainable or pipeable or something else a little bit more descriptive than that. So let's go through kind of what pipe actually does, and talk about why we're using this. So, like we said, the patching of observables became problematic in the fact that everyone was monkey patching the observable prototype, to adding their own operators, and it's really not discoverable when you kind of do that, and somebody else is mucking with the observable prototype, and it could have changed with any of the libraries that you brought in as well. Is that global Rx could have been patched by anybody. In addition, those operators are not tree shakeable because they're sitting right there on the prototype anyways. So what can you do at that point? So the pipeable operator was more of a way so that we could create observables really easily, and then we would have this as a notion of being part of that. So let's actually dive through the code, and because sometimes it's the easiest way to realize what we're trying to do. So let's go back here and dive into the code. So if we go into source, we go into internal, and we go into observable, not observable, but operators, and actually not, let's look at observable. There we go. All right, so if we look here for pipe, okay, and then we have pipe array. All right, so if we go and look at this, what exactly is this? So each of these things is an operator, takes 0 to n many operator functions. So just to try and make it type safe, because, well, this is a kind of a pain in the butt. But what exactly is an operator function here? And an operator function is from the types. So if we go in and go to our types once again, looking at operator function, is it's something that has a extends observable, so it has an operator function, and that it has a notion of this basically. So there's this notion of the that each of these particular things are operators. In this case, we have the monotype operators, which are, takes t and returns t. We have an operator function that could return a result, sort of like map, and so on and so forth. So let's go back into observable and look at pipe again. Where was that? Pipe. Okay. There we are. So pipe basically says any number of these operations we can pipe from array. Now pipe from array goes into util and pipe. So if we go in here, util and pipe, kind of tells you what we're doing here. So we've got these unary functions that we can kind of do, which is to say that all we're really doing is calling reduce on these. So calling the previous operation and reducing it on our current one. So this is basically using the array extras reduce along the way, just to say, okay, this operator depends on this one, depends on this one, depends on this one. So you're chaining a bunch of these unary operators together. So that's all it really is. It's a very, very simple kind of thing that let was basically kind of the same thing, because it would just call the function on whatever you gave to it. So anyways, it was kind of an interesting way about exposing a way that we could do multiple operations at once, and with the ES, the ES array reduce, then we were able to do that pretty easily. So let's actually look at one of the operators that we probably use some of them the most, and that is map. And the idea behind map is pretty simple. It's just it's just a simple way of mapping, taking the current value and mapping it to the next value. So, for example, if I want to extract a property from an object, I can say take my current object, such as a mouse movement, and project that from the event type just to the X position or Y position or any of those in particular that we can do. So map, kind of an easy understanding, because in JavaScript it's pretty well defined too. That map, array.prototype.map, same kind of thing. And the way that we designed Rx from the very beginning was to make it so that if you knew how to program on arrays, then you knew how to program on observables. There was no real difference between the two, other than the fact that arrays are pool-based and observables are push-based. But if you knew one, you knew the other. So that's kind of cool that that you have that ability to kind of transfer your knowledge between the two. People say that that Rx can have a steep learning curve, and one of the responses that I usually have is that, hey, you understand programming with arrays. How are observables that much different, other than the fact that these are infinite, an infinite number of values, unlike an array, and that you can transform them, you can filter them just as you would with the static data in an array. So anyways, what exactly does the map operator do? Well, let's take a look at the map subscriber to kind of try and give you the internal guts of what you're trying to do, because as we realize here, we have our function map which takes in our projection. So it's assumed that this right here is actually our source. So when you've got this unary operator, we have a function inside that returns the observable. So you're always given this this source here, so that source becomes your this at this point. And if it's not, obviously if project is not a function, then it's going to say, well, did you really mean map to? Which is trying to be more helpful about the errors that you do have in there. And our map operator is nothing more than just an implementation of the operator, and all of our operators follow this particular thing of T to R or T to T or what have you. So inside, it basically calls source.lift, and lift basically just applies the source to our particular map operator and so forth. But what's always the more interesting is the subscriber logic, which is where we usually have all of the goodies for our particular operations. So we'll talk about map and filter today, as those are some of the more common ones. So what we have is when the next value comes through, we can get our result, which is basically calling the projection on the this arg. So just as the array extras has a third parameter, or rather second parameter on array.prototype.map has a second parameter for this arg, so you can change the context. And this is really for legacy standpoints that we're trying to mimic array prototype extras as much as humanly possible, even to the point of array.prototype.flatMap, which is a brand new one, and flatten. Both of those are relatively new, and they still follow the same kind of logic with the whole this arg. So what we always have to do in Rx is we always guard against something bad happening. So our projection call could throw an error, for example, and we had an example of that in one of the previous videos if you go back and watch that. Well, what happens is that if for example your projection throws an error for whatever reason, so you just decide that it's a bad value and you just want to end the stream, you can throw an error. And what that does is that takes the error and then shoves it onto the destination, and therefore the stream will be halted by this particular error, so that we won't continue. And that's useful, like I said, is because if something bad happens, and it could be that something in your projection code is just completely wrong, versus some sort of API that you're calling gets bad input. We don't distinguish between those two, so it's good luck on terms of finding what the actual error was, but just know that there was an error that happened there. And then we just send the destination to the next piece. So let's dive back into code here and show you how to actually use map. Pretty simple stuff. So we've got import our map from there, so we can and we can have of. So let's create our first observable. So obs dollar is equal to let's say of 1, 2, 3. And actually no, let's do foo bar and foo bar baz, because I'm just so darn creative. All right, so we have our observable here. Now what we're going to want to do is why am I using var anyways? This is 2018 here. So I can say const let's see, const piped is equal to, now here's where the magic comes in. So you can say of dot pipe, sorry, not of dot pipe, observable dot pipe, which is conveniently there for us. And we can say map. And what does map give us? But once again, as we dived through the code, we saw that that there's this projection that we can do, and it gives us not only the string value that we currently have, but also the index. And that's important is if you're wanting to do any sort of logic based upon where it happens to be in the index. That's pretty important. And once again, we're mirroring everything that's in array prototype map anyways. So we can say, we can project this to be, returning the length of our string here. And then we can just, we can subscribe to it here, and do dot subscribe, and passing in next, console.log, and next. Okay, cool. All right, and then we can run that by just doing npx ts node of 0, 7. Gosh, we're already on the 7th day already. And sure enough, we will get the length of our particulars, which is 3, 6, and 9. So once again, it's a pretty simple operation, and to compose these together is actually fairly easy. So let's take a look now back at pipe and see what we can do there. At filter, rather. So filter is another way of projecting, in that you're going to want to remove things from the collection that you don't necessarily want in there. So, for example, if I wanted only odd numbers or even numbers, pretty arbitrary stuff, or something that hasn't completed, whatever flag boolean that you happen to want is there. So, looking at the function here, once again, this follows the array prototype extras, in that it has the predicate with our current value and our index, and then you return boolean for the most part, or something that's booleanable, meaning true or false. So in our particular case, let's take a look once again at the subscriber, which really tells us the logic of what we're doing here. So it's going to say try. It's going to try and get the result, and catch and forward if the projection function happens to error for whatever reason. So if the result is truthy, because like I said, anything that's truthiable is available to be filtered, whereas in a lot of other languages it's more along the lines it has to be true or false. In the case of us, it's anything that's truthy, which means it could where it's 0 is it's alike, and anything else is not alike. So that's pretty easy to understand in terms of I just wanted to pluck things out of or remove things from my collection. So going back to our code here, we can now import in our filter. So let's bring in filter. So now that we've got our length, we can once again add on n number of these operators here without affecting our bottom line. So we can say filter. Now remember, we have only numbers here, the 3, 6, 9. So if I said x mod 2 is equal to 0, I would only get one item because one of those items happens to be 6. So running this through again, we get our next of 6, and that's it. But like I said, it's a nice composable, chainable kind of thing. And we'll dive deeper into some of the more advanced scenarios, because you can have, once again, inside of here, you can have operators be piped to other operators to be piped, and so on and so forth, so that you can create these kind of nested ones through any number of ways. So it'll get kind of complicated, but that's why we have these operators that for concatenation and merging and so on are static, so that I could bring in merge here, and I can merge this with something else. Of course, merge is not an operator function. We would have to create it in such a pipeable way, so that we can merge things together. But that's for another time, really. So let me just quickly try and close this off by just having an error occur here. And like I said, I really just want baby steps here for people to understand what RxJS is all about, is because if you understand the basics of array programming, then you pretty much understand the ways of everything else. So here we could have, instead of the filter returning that, we can just say, throw new error, and bad things will then happen, in that it will get to our map function, but as soon as it gets to our filter function, it will throw an error. And because of the code that we saw earlier, where it does the try and catch on our projection, that's how it's caught and that's how it's forwarded, so that we can do some error recovery if we need to. So with that, if anyone has any questions, like I said, always just put them in the channel, and I hope to get to those particulars the next time around. So anyways, we've reached the 30-minute mark here once again. So highly encourage you to check out Rx. I will be posting this lesson that we worked through here very shortly, with lots of kind of the data that we talked about here, which is how we went from what we went through with the dot chaining to these pipes, and what exactly these operators are going forward. So with that, I'd like to thank you very much for showing up, and I will catch you next time. Thank you.